this equation here, the roots of the equation, x squared plus 2px plus q equal to 0, differ by 2. Show that p squared is equal to 1 plus q there. Alright, so our main focus here is this word that we have here, differ by 2 here. So meaning that the difference between the two roots that we have should be positive 2 here. So for us to get a positive number, it has to undergo the modulus there. So meaning that here, the modulus of the difference of the two roots, meaning that if we have alpha minus beta here, this should give us 2 here. So now, to get rid of these modulus symbols that we have here, we can just square this. So this will just basically give us alpha minus beta squared. So we square both sides. So alpha minus beta squared will be equal to 2 squared like this. So we're going to get alpha minus beta squared is equal to 4 like this. We're going to keep this for now here. It will come in handy. Now, when you look at this expression that we have here, okay? So when you look at this expression that we have here, you'll notice that our a there is 1, our b, so we have that our a here is 1, our b is 2p, and our c is q there. So if that is the case there, the other thing that we know here is that the sum of the two roots that we've been given, if we add alpha plus beta, we're simply just going to get negative b over a here. Then negative b here, we have negative 2p divided by a, we have 1. So it will just give us negative 2p like this. Then the product alpha beta is simply equal to c over a here. So our c is q, our a is 1. So this will just give us q like this here. Alright. So now, after getting this here, we need to show that the expression here is going to give us this here that we have here. Now, if you look at this first expression that we have here, so let me name it 1. If you look at this expression that we have here, there's this identity here, the quadratic identity that we have, which is alpha minus beta squared here. So we need to find the expression for this, and then we also plug in these values of alpha plus beta and alpha by beta that we have here. So now, finding the expression here, alpha minus beta squared, the expansion of this here will just be equal to alpha minus beta and alpha minus beta like this here. Then we expand this further, we have alpha minus beta squared. So alpha times alpha, we get alpha squared. Alpha times negative beta here, we get negative alpha beta. Negative beta times alpha, we get negative alpha beta. Negative beta times negative beta here, we get positive beta like this here. Okay, so we have alpha minus beta squared is equal to alpha squared plus we have beta squared and minus, so this is negative and negative there, so minus 2 alpha beta like this here. Now we have another identity again here, which is alpha squared plus beta squared here. Now remember that alpha squared plus beta squared is simply equal to alpha plus beta squared minus 2 alpha beta like this here. So therefore, where we have alpha squared plus beta squared, we sub with this identity that we have here. So we have alpha minus beta squared is equal to alpha plus beta squared minus 2 alpha beta, then minus the 2 alpha beta that we have here, like that there. So then we have alpha squared or alpha minus beta squared is equal to alpha plus beta squared minus 4 alpha beta like this here. So since these are like terms, we can just add them like that there. Now we have the value here. Okay, so we have the value of alpha minus beta squared. So the value of alpha minus beta squared is 4. So meaning that we can just substitute with 4 where there's alpha minus beta squared. So 4 here is equal to minus alpha beta, we have q there, so we substitute with the q where there's alpha beta, so 4q like that there. Okay, then now here the expression we're going to have here is 4 is equal to negative 2 squared, we get a 4, p squared, we're just going to have p squared minus 4q like this. Then we can make 4p the subject. If we make 4p the 4p squared the subject, we're going to have 4p squared is equal to 4 plus, if this process the equal sign becomes positive, 4p or 4q like this. Then we can divide throughout by 4, we divide by 4, we divide by 4 here, and we also divide by 4 there. So therefore we have p squared is equal to 1 plus q like this. So therefore we've shown to say that if the roots differ by 2 here, then p squared is equal to 1 plus q here, which is this expression that we have.